Hey, I'm Mitchell. Welcome to another video in the RSP Education series. Ever wonder how industrial systems seem to automatically stay on track, no matter how complex the process? Whether it's keeping a reactor from overheating, balancing pressure in a pipeline, or making sure a product comes out exactly the same every time, there's one thing behind it all, and that's control loops. They're the brain and nervous system of industrial automation, quietly working behind the scenes to keep everything stable, safe, and efficient. In this video, we're going to break down exactly how control loops work, what makes them so powerful, and how they're used in real-world industrial processes every single day. By the end, you'll be able to understand not just the theory, but the practical, real-life pieces that make it all happen. If you like this kind of content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. So what is a control loop? A control loop is a system that automatically adjusts the process to maintain a desired set point or a target value. Think of it like your body's reflexes. If you touch something hot, your nerves or your sensors send a signal to your brain or the controller, which tells your muscles, the actuator, to pull away. Industrial control loops work the same way. So first you have open loop control. This is no feedback. The way it works is the system runs without checking if the desired outcome is actually achieved. For example, a toaster. You set a timer, but it doesn't check if the toast is actually browned. In industrial use, simple processes where exact control isn't critical, like conveyor belt timing would come to mind. Closed loop control. This is feedback based. The way it works is the system constantly measures the output and adjusts to match the set point. For example, like the cruise control in your car. It measures speed and adjusts the throttle to maintain it. That's an example of a closed loop. Industrial use, right? Critical processes like temperature control in chemical reactors, keeping it at the right heat or the right temperature. Key parts of a control loop and how they actually work. So sensor is the eyes of the system. It measures physical variable like temperature, pressure, flow, etc. The way it works is it converts a physical signal into an electrical one, like a thermocouple generates voltage based on temperature. An example would be an RTD that's measuring temperature by changing resistance. Then you have transmitter or the messenger. What it does, it takes the sensor's raw signal and converts it into a standard format like 4 to 20 milliamps, digital HART, or foundation field bus. The way it works is it amplifies, filters, and conditions the signal so the PLC can read it accurately. An example would be a pressure transmitter converting a diaphragm's movement into a 4 to 20 milliamp signal. Then the PLC, what it would do, it would compare the sensor reading to the set point and decide corrective action. The way it works is it runs a PID, or a proportional integral derivative algorithm, to minimize errors smoothly. For example, if a tank's temperature is too low, the PLC increases the heater output. The actuator, the muscle, it physically changes the process. It's going to open or close a valve or adjust motor speed. It works by receiving a signal from the PLC, like 4 to 20 milliamp, referring to a valve position. An example would be a control valve adjusting flow based on the PLC's command. Another real-world example would be a temperature control in a reactor. The sensor, let's say it's a thermocouple, it measures reactor temperature. The transmitter converts the signal to 4 to 20 milliamp and sends it to the PLC. The PLC compares temp to set point. If too low, it sends a signal to open the steam valve. The actuator, the valve, it opens and it allows steam to heat the reactor until the set point is reached. The reason why this all matters in industrial automation is efficiency. This is going to prevent energy waste by adjusting only when needed. Safety, it avoids overheating, overpressure, or other dangerous conditions. That's closed feedback loop, for example. Consistency, it ensures product quality by maintaining precise control. So let's recap what we covered. We talked about what a control loop is, how it works, like the reflexes in your body to keep industrial systems running smoothly. We broke down the differences between open loop and closed loop control and why feedback is so critical in most industrial processes. Then we walked through the 4 key parts of every control loop. The sensor, that's the eyes that detect changes. The transmitter, the messenger that formats the signal. The PLC, the brain that makes decisions. and the actuator, the muscle that takes action. We looked at a real-world example, temperature control in a reactor, to show how everything works together in real time. Control loops are everywhere in automation, and now you've got a clear understanding of how they work and why they matter. For hundreds of thousands of other industrial automation products, go to our website at rspsupply.com, the internet's top source for industrial hardware.